Live from New York, it's Ask the Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada, the engineer, with me, Mr. Lady Ada, on camera control. We're broadcasting live from downtown Manhattan in the secret underwater headquarters. I don't know.
Did you ever watch Sequest? Do you remember that show?
I do remember Sequest.
It's cool.
Yeah,
Anyways.
I have a submarine. We're under the boat. So we got an exciting show for you tonight. Lots of new products, lots of videos, lots of tutorials. A lot of guides went live this week. News and more, including some amazing, it's not out yet, and preview vids. So stay tuned till the end. Of course, we answer questions then as well. Mr. Lady Ada, tell them what's on tonight's show.
On tonight's show, the code is Packetfruit, 10% off in the Adafruit store, all the way up to 11:59 p.m., or when I remember to turn off the code. Talk about our Adafruit live shows, including Show and Tell. Thanks, Liz, who just hosted. Go over a little bit of what was on Lady Ada with a special treat, because we had some fun over the weekend. JP's Product Pick of the Week highlight. Very special mailbag. We have the continuation of Marchintosh with some retro tech. We've got some Made in New York City, advanced manufacturing, factory footage. Got some 3D printing, INMPI, a bunch of top secret. New products. We're going to answer your questions. We do that over on Discord, adafruit.it/Discord. Head on over. We answer those during the show, and of course at the end of the show. All that and more on, you guessed it, Ask an Engineer. So, Lady Ada, remember, code is Packetfruit, and we have free stuff.
Beep,
So,
beep.
in addition to the code, when folks add stuff to their cart to get free things, the first tier that they'll notice is...
I think we still have $99 or more half-sized Perma Proto breadboards, although they're running out.
Yes.
They might already be out. But $99 or more. If we have them in stock, you'll get a half-sized Perma Proto, great for taking your solderless breadboard projects and making them permanent. We do have plenty of KB 2040s, I know, because I just checked stock. Pink circuit boards with an RP2040, 8 megabytes of flash, STEM QT, buttons, USB-C, a great microcontroller. Upgrade your Pro Micro project with this dual-core 133 Cortex M0 chip. Ooh, fancy. $199 or more, you get free UPS ground shipping in the continental United States. And $299 or more, we have, yes, once again, the Circuit Playground Express, our all-in-one dev board with LEDs, buttons, sensors, chips, and more that runs Arduino, MakeCode, Code.org, CS Discoveries, CircuitPython, and even MicroPython these days, as well as other exciting platforms. So great to see the SAMD21 back in stock. That's free with your orders at adafruit.com.
Okay, we do a bunch of live shows. We do these every single week. We just wrapped up Show and Tell. Like I said, thank you, Liz, for hosting. There's a whole bunch of things that you can watch on Show and Tell. Hard to pick one. However, we were watching it because even when we're not hosting, we're watching. I did like Mark's project that showed a mag tag that you can blow out a candle on the screen, and it actually blows out the cupcake on the screen in real life on a Funhouse.
Yeah.
Mag tag. Was really cool. So do check that out, and you'll see some projects from our team, and then also projects around the community. And if you want to see a really weird retro device that we're modding to turn into a musical instrument, check out this Computer Perfection thing, and then find
I heard the ad is ridiculous.
And then find the ad,
yeah.
Which is really fun. It's super weird. Okay, we did a desk of Lady Ada, and for the folks who watched it, this was the intro.
And welcome to Desk of Lady Ada. Today we'll be doing a teardown of me.
That's right. You could talk about what was in the beginning of the show, but part of it was, and I'll play the little snippet of our kiddo.
We killed the cactus.
Interacting with this cactus.
Yes.
But we did do a teardown for this pretty popular, TikTok toy. It's called a mimicking cactus.
Yeah,
you showed some other stuff.
It's a mimic dancing cactus, and you were like, "How do they do this?" And I was like, "I don't know. We'll buy an extra one. And we'll skin it alive, and take it apart and see what's up." And so, it's got this chip by Jay Lee. You can see it in the video where you kind of figure out what chip it is. It's like a little microcontroller with an 8051 core or something, but has built-in microphone amplifier, built-in Class D or Class AB speaker driver. And some GPIO, just enough memory to basically run a demo where it records audio and then plays it back at a higher speed. And then we talked a little bit about audio projects. and how you could remake this with a chip that you didn't have to buy.
Yeah,
From.
yeah.
Oh, we also did a low power demo for the new e-ink feather, just showing how I calculated and verified the low power usage using CircuitPython, where we have deep sleep support, and then verified it with a Nordic PPK too.
So here's a video that we showed. We're not putting our kit on the internet. Like pictures of her face and stuff. So I blocked out the area, but you can see what this is, and you can hear her. So here, I'm going to show you a little video. It's cute. And then we did the great search. This is brought to you by DigiKey and Adafruit. Late user powers of engineering to help you find what you're looking for on digikey.com. What did you help people find on Lady Ada desk
Well,
this week?
doing this Cactus teardown reminded me of so many of the projects I did in school where we didn't have microcontrollers that could do audio, like having, we had like 2K of RAM at the most. That was considered like super amazing and huge. So the chips now that can, buffer and read audio and playback are amazing. But what you would do at the time is if you wanted to make projects that had audio prompts, so like you would record and it would play back sound effects, what you would use is an ISD chip. And these are chips that were specialized for recording and playing back audio. And they could record and play back 30, 60, 90 seconds of audio. And you could also sometimes have, within that memory, you could sub-clip it. So you could have 5 clips. And it was GPIO controlled, so you didn't even need a microcontroller. They're really easy to use, and they work really, really well. And the quality is good enough for audio or some simple sound effects and props. And so I realized a lot of people don't remember or know about the ISD chip series. And then went to DigiKey. It was wow, there's still thousands of these in stock. They're very popular, and a lot of options are used, including one that was 60 minutes long. So check it out if you want to make a prop and you just want to record an audio effect or even send it over SPI, where you can use a microphone on the board, or you can send the data raw, and then all it does is play back that audio without any external chips or even external components. It's dead simple. Check out the ISD series. The company was purchased by Nuvoton, so that's the current maker of them.
And then, of course, there was JP's product pick of the week. I sent JP and you a link to an article. So Amazon tried to do, and also TikTok in the US, tried to do the, they're calling the Chinese style of selling things online. And it turns out it didn't work. Amazon had live videos during shopping. TikTok kind of does. But they were trying to reproduce a style of video that was happening overseas, which is you're watching from a product page, essentially, a live video. And as people are buying and doing things, the price might change, the number of accessories that you might get with something might change. And it's a very interactive live. It's like whatever you think.
It's QVC, yeah.
It's right? QVC, but times a million. And so Amazon is we're going to do this. And I've been watching other entities in the e-com space. Kickstarter had a live video that I think I wrote about, and then I didn't see anyone use it or even talk about it or anything. And that was a neat idea, I thought, because if it's a Kickstarter, you really want to do lots of updates for your backers. And then I think Etsy had something. We're using Tumblr Live, but they have a store interface. But there really isn't a U.S. version of what happens in other countries with this live thing. And we have our little corner of the world, which is Adafruit. And it's the closest thing, I think, because JP's broadcasting live from the product page. The product that we're talking about is on sale. You don't have to put any codes in. And the community is interacting with what's going on for that particular project with the maker there.
Yeah.
So anyways, kind of interesting. We're trying to always figure out ways, how do we be an innovative company that sells stuff that can stay independent, not put ads on our site, not take venture capital or loans or anything. Not to dunk on that, works great for some people, but we really want to keep our open source values and everything, so we keep experimenting with this stuff. And so far, looks like the product page and this show and a lot of other things we do seems to make a lot of sense.
It can be very popular. I mean, sometimes we sell. We try to reserve about 100 pieces.
We'll
and
sell out
sometimes
of
we
this
sell out
stuff,
in a few minutes.
So anyways, sometimes we have a maker business segment, but one of the things that we get asked almost on a daily basis is like, hey, I'm thinking of starting. I have a little product that I want to sell, and it's like, what should I do? I'm like, publish something every day. Maybe it's the code, maybe it's a story about how you're shipping stuff. But one of the things that we do is from one of our product pages have a live video. So take it away, JP, this week's product pick of the week.
It is the NeoKey BFF. This is a little best friend forever add-on for a Cutie Pie. So take your Cutie Pie, take your BFF, marry them together. This one allows you to take a Cherry MX compatible mechanical key switch, plug that into the socketed receptacles for the 2 pins there, and now you have a mechanical key switch. I've put it in a very minimalist configuration with header pins, so it's just plugged right onto the bottom. It has a reverse mount NeoPixel, and then it has the sockets for a mechanical key switch to plug in. You can see it in action. When I press it, it is glowing red, and it's also sending a USB HID command to my broadcast software to bring on a delicious plate of gnocchi. It is the NeoKey BFF.
Thursday, Jobworks Workshop, and Friday's Deep Dive with Tim. Mailbag.
Letters. We get letters. We get tweets and we get emails. Your comments via RSS.
This week is kind of a special mailbag because this is really nice. It was a long day, and we got this email in, and we have a weekly.
That's nice.
Yeah, we have a weekly all-company meeting. Some of it's in person, some of it's virtual, and it's called State of the Fruit. And we read this right away because we're like, this is great. So this is from Brian. Brian says, I just have to say, you single-handedly, through all the many hands at Adafruit, helped me make almost all of my most favorite things I've made, from your amazing tutorials to your products to your community to the forum and Discord. I literally could not be where I am without you. There is not a single entity out there in the world that's been more consequential for my professional work than y'all, and I didn't have, and I can't thank you enough for being exactly who you are. Thank you from the bottom of my heart. That's really nice. Very nice. That was great. That felt good. we like nice emails. Like
That's a nice email.
Yeah, it's nice emails. Let's do some retro.
And at no point at the end of the email did he say, "So send me a Raspberry Pi."
Yeah. But by the way, I really want a Raspberry Pi.
Yeah.
Here we go.
Most emails are like that nowadays.
Yeah. I got a voicemail and someone's like, I absolutely must have a Raspberry Pi. You absolutely must get me one now. It's just like, man. Like,
I'll be at your place
yeah,
at
it's like
1:30
I'm
and I'm
standing outside your window. It's like,
whoa.
Okay. Let's do some retro. Okay, retro tech. This is when we look around and maybe look back to build a better future.
Back. It's like time travel, but only backwards.
Yeah. So this is still Marcintosh, just for a couple more days.
Oh, we're nearing the end of Marcintosh.
And this is all retro Mac stuff. And so this week, and you can check out these. This is the Apple II. This is Apple II Plus.
Ooh.
And did you have one of these?
Oh man, I didn't have one at home, but we had them at school.
Yeah.
Yeah. Boy, did I type many Apple logo and Print Shop Pro.
Lots of Print Shop Pro.
Lots of Print Shop Pro, and I played a lot of Where in the World is Carmen Sandiego.
It was like Karateka. That was one.
Was Karateka?
Yeah, it was like a karate.
That's cool.
Karate thing.
Yeah. There were a lot of good games for the Apple II.
Yeah. And so that was part of our retrospective.
Yeah,
and
you
then,
can tell this from a school because that's like that security kid on the side.
Yeah. And then this
My favorite.
This is your favorite?
My favorite. My favorite. It's the best. I could actually probably still do a majority of my work on a Mac SE30. This was a bitchin' machine. This was a good machine.
Yeah.
Yeah. It was a 68030, right? I think that's what the 30 stood for. It had the expansion slot.
Look at this.
Yeah, which you could connect an external large monitor. It had SCSI. Go back to the ports.
You want to go back to the ports?
Yeah, let's go
to the ports.
Okay. You had the expansion slot. You had the disk controller, SCSI, modem, ADB, keyboard, mouse. You could connect to the internet with this.
Yeah, so this was 1989. Came out January 1989, and then all the way up to October
Identity
91.
floppy.
Yeah, and this was the fastest model with the original black and white.
That's right.
Compact style.
It was really good.
Yeah.
Yeah, and you could get internal hard drive, I think, and up to 128 megabytes of RAM, which is it's a lot for what this is.
Yeah, and a 1.4.
What was the speed? I don't remember what the megahertz was. I think it was like 40 megahertz.
Yeah, this thing was cool. And the other thing that it was kind of known for was it was used to publish. I think there was a magazine, or a newspaper specifically. Like they did it all on one of these machines.
Yeah, no, you have this.
Yeah.
You could connect a radius portrait.
Yeah.
Remember those? This monitor weighed like 87,000 pounds, but you could rotate it from portrait to landscape. It was amazing.
Yeah.
Yeah, I remember when my dad had one for when he did his writing, and then it passed down to me, and then I remember like in my high school we ran Quark Express on it, and that's how we did the high school newsletter. We did maybe it was PageMaker. We did page layout again on this portrait display. 60 megahertz.
And then next up, so we have a poster from Susan Kare, and I wanted to make an observation.
Yeah.
Because it's Macintosh and everything, and you always hear about Mac and design and Jonathan Ive, and from back in the old Mac days, you hear about Guy Kawasaki.
Yeah.
But you don't really hear about Susan Kare, and she's responsible for the entire. She's a creative director during this Mac time, and then also at Next.
Yeah.
And
great icons.
Yeah, fantastic icons. Still an artist doing these things. But these are like the iconic things of computer science, computer history. And so I dug up an ad. It's like a mini ad with her in it, and then a little 5-minute interview with her on Computer Chronicles, because it's Women's History Month, and also when you think about like Apple. There's only like 2 or 3 names, and it's usually not hers. So I thought, well, maybe we can, remind folks, or maybe they don't even know, like, where did these cool icons come? Like, who made that floppy icon? Like, a lot of things that we kind of take for granted. There was someone who designed these. So I was going to play those, and then we'll do Python on hardware after this.
Move.
If you're an artist and you're skilled with media, this is a new medium that offers great control, turning off. There's 1,000 little dots in ½ an inch, and you have the capacity, either real or magnified, to turn off and on each one of those dots. So in a screen that's fairly big, or a piece of paper 8.5 by 11, you've just got so many scads of dots. There's nothing really that you can't present on that screen. All you do to print, unlike most computers where you hit a control key and a print key sequence, you just hit one button. It says print, and it prints. And you can actually Bill-mate it so you can watch on the screen the whole document gradually being printed and follow your progress. It's pretty nifty. Certainly, I think one of the best experiences is seeing a person who's never used a Lisa before or a Mac before, and even never used a computer before. It is possible, easily possible, to teach most people to use one of these computers in about 20 minutes. And a lot of that is because you can explain what an icon means, and a person can remember it easily. So we certainly used Lisa as a jumping off point, and making just some refinements and additions for some new features. What you see now is the image, the icon that you get when you just plug Mac in and turn it on. It prompts you with a picture of the diskette, saying, I need something.
Okay,
so that all you do is, it only fits in one way, so there's no way you can break it or make a mistake. You just pop it in. You get an image of a content Mac, so you know that everything is okay and you're welcomed. It's just so that the person using Mac gets information all the time visually, so nothing has to be translated. A little wristwatch to tell you, just wait 1 second.
Things are happening. You've replaced the salt timer.
Yeah, we're moving into the 80s.
So what do we have now?
So what we have now is an image on the screen of the diskette that we put in the slot, and it can be with the mouse. It can be moved.
Okay. And it's already showing you the name of that disk.
Right, and it's highlighted in the sense that it's inverted, so that Mac knows that you want to do something to this diskette, and your choices of what you might want to do are listed in hidden menus that operate a little bit like window shades. When you move your cursor, right, that are choices. We could find out something about this diskette, or we can just open it, or we could eject it. But if we open it, just say open, and immediately you get what we call a window that displays graphically and in words what is contained on the diskette in the machine. So you can see there's a picture of a hand painting, which symbolizes a paint program, and a handwriting for the word processor, and a couple of memos that were already written, some folders. If, say, you want to store a document or two in a folder, it's analogous to life. You just put the piece of paper in the folder.
Now you've got something called the control panel here. Show me what that is.
Always available to you are a number of desk accessories. So you move the cursor to control panel, let go of the mouse button. So this, which looks a little bit like a dashboard, lets you fine-tune the system in a number of ways to your comfort level, or just your personal preferences. The computer will work no matter what settings. So say, here's a little volume control. You can see the speaker. So every now and then you hear a beep with Mac when you turn it on, or sometimes during applications. If you're at home by yourself and you're listening to the stereo, you might want to know that you'll always hear those beeps. If you're a student working in the library, you can move it so that just the bar will flash, so there's no noise at all. Say some of the other features let you adjust keyboard repeat rate, or a menu flash, or the amount of time between double clicks, which might vary with the age of the person. Pop the control panel away by just clicking on it. And Notepad lets you, while you're working in any application, as well as just this, what we call the Finder, which is like a directory, be able to grab the keyboard and write a note to yourself. Remember to read page 12. And you could say, put this away, or you could move it over. We can go to page 2, where it says another note, one left for oneself. Flip to page 3. Up to 8 pages of notes that could help you in your work or just remind you of social events.
One of the items was Scrapbook.
Right. Scrapbook lets you keep literally, you're only up to 256. You're only limited by how much memory you have free. Pictures or messages or documents always available for the terms we use are cutting and pasting. Right. So say to open a word processor application, you could click on Mac Write and say open. If you want to get right to a document, which automatically launches the application. Same procedure, which is why it's easy to use. We're loading the word processor and to the specific document that we can. Here's an old little bit of sample text. This is how the word processor appears to you. A ruler lets you set formats, which is certainly a familiar object. Say you want to go from single to double space, just click on the wider image if you want.
And you can justify or center. We're not going to have time actually, but you could have pulled up pictures from Mac Paint from the scrapbook and then insert them into the document.
Paste them in just by saying paste from the menu. If you want to change a word to be bold, just say bold. Change the font to something like Old English.
right, it's Python on hardware time. This week, Lady Ada, we've got a lot going on in the world of Blinka, CircuitPython, and more. Let's go over to our newsletter. So this week, one of the things that we did last week was talk about the 100 libraries in the community bundle. So that was breaking news.
Breaking news.
Last week. I do want to thank everyone who's in our Discord. We're up to 37,000 people. Thank you. It's one of the biggest open Discords. Thanks for keeping it a good, safe place for everyone. And this is kind of a neat project. We're starting to see a lot of, especially Python-based projects that use hardware with ChatGPT. And again, our point of view, in case y'all are wondering, is this is a fantastic thing to generate gobs of text for fiction. So this is kind of neat. This is a Raspberry Pi that'll pretend to be clippy and move around and say things. So, if you want a paperclip to talk, ChatGPT might be for you. And then we watched some of the Arduino. It was Arduino Day, and it was also Hackaday Berlin. A lot going on I think it was Saturday, even with time zones. And there's a new Arduino Uno R4. Unclear. Theoretically, it could run MicroPython.
It could run MicroPython. It's ARM Cortex, which is good, and it's got a 32K of RAM, which is enough. I mean, that we have the SAMD21 with 32K of RAM, so it's not a ton, but it's comparable to the SAMD21. What's interesting about this chip, it's a Cortex M4, so it's much more powerful than the SAMD21. And it's a 5-volt logic microcontroller, which is it's a rare thing, right? Not a lot of microcontrollers that are ARM Cortex run at 5 volts and have USB. So it'd be interesting if if there was a lot of demand for 5-volt logic level support. This would be like the chip you could use it with. Yeah,
we'll see if folks want this. This is a different direction for Arduino. We shall see. And then some new firmware for Microbit. A good comparison on some hobby PC vendors. I asked Ann to put this in the newsletter this week because we get asked a lot. It's like, I wanted to send out my PCBs. Which ones? And we like Oshpark, but then someone went through and just here's the one from DigiKey. Here's Oshpark. Here's this one. Here's this one.
And a lot of these PCBs also, I really like that pastel purple joystick cover.
Yeah. It's kind of cool. Anne was on the Hackster Cafe, and then I wanted to have you, Lady Ada, talk about the new things that we just added or adding in CircuitPython. There's the GIF thing, and then the IMX.
Yes, we've got a couple good
things.
Like
today.
A little translucent. I really like this. This is a very comfy green shirt. So sorry, I know I always wore black.
Adafruit is so transparent.
It's so transparent.
You can
literally
see right through her.
Okay, so number one, GIF.io is now merged into the latest builds and will be in the beta 1 release. Thanks, I think, Mark and Anne and Dan and Jepler, who all helped out getting GIF.io in. So it's cool. You'll be able to play GIFs natively from within CircuitPython to any display. That's super cool. And we also have optimized memory management now, so you can switch out GIFs because it's GIFs are kind of weird. So you can play them from disk. And also, Jepler did a bunch of work to add I2S and PWM output for the IMX RT series, which is also really neat. You can play, he did some tests. I was like, okay, this is a 500 megahertz processor, the Cortex M7, and it has all the FPU, DSP commands that come with the Cortex M7, so it should be able to play a lot of audio very quickly. So it can currently, I think, play 4 to 8 concurrent wave files off of an SD card, where the SD card is clocked at 25 megahertz. So I think it's limited by the speed of the SD card, and there's no SDIO support on
4 at the same time. That's pretty cool.
Yeah, 4 to 8.
You'll be able to do.
Yeah, which is pretty good. Concurrent wave playback. So the next thing would be to, if you're limited by the disk size, I actually wonder if MP3 might be a little bit better, because with MP3 it's a tenth of the disk size, but there's no more CPU requirements. So it kind of depends on whether it's CPU bound or if it's disk bound. I might have Jepler try that out next. So those are the two of the things that I think. I mean, everything is wonderful in CircuitPython,
of course.
But I'm very excited about those two things.
All right, so check that out. The newsletter comes out every single week. We deliver it to your inbox. Just go to adafruitdaily.com, separate site. We don't want anything to do with your email address, so we put it over there. And it has nothing to do with your online store. We don't do pop-ups or any of that nonsense because we don't like that either. All right, next up. We're an open source hardware company. To prove it, we put all of our code online. We put on an open source hardware license, an open source software license, put up all these guides. We do everything we possibly can to help you and everyone out there make stuff using our stuff. So we have these guides.
Okay. So we have 6 new guides. So start go down. So I'll start from the bottom.
You want to start from these?
Yeah. So we've got last week we did the MIDI controlled robot lyre with CircuitPython, but it's still an amazing guide. So go check it out. Sounds beautiful. You can make your own robotic harp without needing a whole harp. A lyre is like a small desktop harp. Okay. So new this week from Noe and Pedro is and a little bit of help from Liz for code is the air quality monitored case. So this uses an SCD41 and a PMSA 3IS something, both STEMMA-QT plug-and-play sensors for air quality, particulate, CO2, humidity, and temperature, humidity, CO2, and particulate matter. Right, all those sensors with an ESP32S2 TFT built in. Basically, all-in-one, portable, battery-powered, all environmental sensor that doesn't even require soldering, which I think is kind of neat. We're getting really close, Phil, to this like no solder future. We talked to the good Chris.
Chris Anderson.
Good Chris Anderson.
A million years ago, Chris Anderson, Wired Chris Anderson. He was the editor-in-chief of Wired.
The good one.
There.
I say that because it's funny. He's an evil one.
I think there's one that runs TED Talks.
He's the evil one.
I don't know if that's true. And he had said, because he's kind of known as a futurist, and he's still doing futuristic things. He was doing a maker company while he was on his way out of Wired, doing an open source drone company. But he had said, the future is kind of like where we are now. Lots of things like stemma that plug together, and a lot of places, whether it be a office environment or even a school environment, they're just not soldering as much. So we needed to have options for people. So we're getting closer and closer and closer to that.
Yeah.
There's still room for all those things. But I remember he said, because when he was running a business, it was like kits weren't really one of the things that the demand was shrinking, where things like breakout boards and things that you plug in together, more like, I don't want to say Legos, but like things that are more modular.
Yeah, they like Capsella is like one of my favorite toys as a kid. So it's like stuff that snaps together. And you'll see like a lot of, not every board, but more and more boards that come from us and sensors are plug and play, thanks to the quick format from SparkFun and just clever use of such small components.
We have a chart with Grove, Quick, Stemma. There's a couple others that we tried to make sure.
There's a Gravity. There's a couple. So
Yeah.
we're moving there.
We tried to make sure whatever we did was the most compatible.
Liz did 2 guides on our new CAN peripheral boards. One is the CAN Bus Featherwing, so you can add CAN Bus to any microcontroller or the Feather format because it uses SPI. And then we also have the CAN PAL, which is for boards that have a transceiver built in. So like the ESP32 series basically, and the STM32F405. And the SAM E51. Not a ton of boards have built-in CAN peripherals or TWI, TWAI as ESP calls them. But if you do, you could just use the CAN PAL. You don't need to get the SPI Featherwing. So we have 2 options. And guess what? We have the videos of me testing them. I test them against each other. Phil B. wrote an awesome guide about the new Pico DVI Arduino library. So the RP2040 can do a lot of cool tricks with PIO, and one of them is you can have DVI output that works on HDMI monitors. But the Pico DVI library, would normally require using the Pico SDK, which is, amazing and powerful, but a little challenging for people. The Phil B. wrote a wrapper library for Arduino that takes Pico DVI, kind of does all the work for you, so you could treat it just as a frame buffer display that's 320 by 240, and it will automatically, magically come out the Pico pins, and then you wire up a DVI HDMI connector, and then you can have it go to any monitor. So we have a DVI Feather coming out soon. There was a little silkscreen error, and I wanted to get the boards remade. But once that's out, it'll work magically with this library, so you can really easily make projects that connect to a monitor and anything with HDMI input. So you can also do screen captures of Arduino or microcontroller projects, which I think is really cool because you get like beautiful, pixel perfect, rather than trying to like video with your phone or whatever. So you can
Yeah, and
capture
everyone
with an
has
HDMI capture.
these, lifeless black rectangles that have taken over all of our homes, called TVs, and you can make something for them now. Like you can make your own little art things.
Yeah, and we have a little video from Todd too.
Yeah, and it doesn't communicate with a server somewhere. It's all local.
Yeah, and you don't run Linux. There's no Linux. I mean, because people are like, oh, you could just use a Pico W. That's $5. It's like, well, first of all, you can't get that.
Just do Linux.
And second, it's running Linux, and it's like a whole thing.
All you need is to change the kernel.
Yeah.
So yeah,
Okay.
we'll get accused of making art too easy.
Too easy. Next up from Dan Halbert, we've got Deep Sleep with CircuitPython. This got updated. We had a couple of pages that Lucian had written about Deep Sleep and realized that they never went live. Those pages are now live. And also, if you have like an RP2040, you want to do Deep Sleep like I wanted to over the weekend, we have a page on that. So check it out. We actually have pretty good deep sleep numbers in CircuitPython. You'd be surprised. We get as good as it gets, and it works really easily. Like when you're on USB, it doesn't actually go to sleep, so that you can continue to. It pretends to go to sleep, but when USB is disconnected, it knows that and it actually uses the low power because USB is disconnected. We've got HexPad, which is a really cool project. I think you sent me. Someone built like a honeycomb, like a large honeycomb hexpad, and I was like, oh, maybe we can make a little teeny one with custom hexagonal keycaps. So Noah and Pedro and JP worked together to model hexagonal keycaps for chalk keys, super skinny keys, have them sent out to a service so we can get like nice resin prints, but also you could just print them on your FDM printer, and uses a QT Py for HID control. You saw a little video, it does like a MIDI control as well. So we've made a lot of keyboard stuff, but we hadn't made one that had hexagonal keys.
Yeah.
I love hexagons.
And for the last one, I have a video.
Okay, let's watch the video.
This is ChatGPT project. And again, because I think, knives are out. Everybody's like, let's sign a petition. No more AI for 6 months. And then some folks are like, this is just a language model. It's just stringing words together. It's not alive. Like, stop saying that. It's really good for fiction.
Yeah, no, if you want to make up stuff.
It is so much fun for fiction. If you like having, so you could have a kid's story and all that. There's so many fun things that you can do. Another fun trick, and we might do a video of some things it doesn't do, because folks are like, oh, it can make schematics. No, it can't.
Don't worry. If you're an engineer, this thing is not coming for your job.
Yeah, but one of the things you can do, which is kind of funny, is you can tell it, I think it's called system message. So one of the things I did, you are the biggest Cure fan in the world. I'm going to ask you questions, and you have to reply back with lyrics from Cure songs, and you have to put the lyric, the song name, and then the album. And then you ask it
how's your day?
Should I wear a raincoat? And it'll, tell you lyrics of songs. Excellent. It's stuff like that. It's kind of like an advanced form of horoscopes, because you're kind of going into it with things that you want to hear anyways.
Yeah.
Or things that you kind of remember. So for trivia and stuff like that, it's a lot of fun. So anyways, here's an example, a good use, we think, of it, which is a lot of just unending, kind
of nonsense. But it's using a Pico W and CircuitPython, which makes it cool.
Yeah.
Hey, it's Jepler here with my new project called Press Button, Get Superpower. It uses CircuitPython on the Raspberry Pi Pico W and connects to OpenAI's ChatGPT. Each time you press the button, a request is made to ChatGPT, and the response is streamed on the OLED display. Not every response is a winner, but many of them are charming and funny. And if superpowers aren't your thing, don't worry. Just edit the settings.toml file in any text editor, and write your own original prompt in plain English. For example, maybe magical universities are what you're more interested in hearing about. I like how this project invites endless customization even for non-coders. And for those of you who are learning to code, I hope it also provides a good example of using ChatGPT together with CircuitPython. Check out my new guide on the Adafruit learning system today.
And here's some factory footage. All right, and that was our factory. Let's do some 3D printing. All right, we're gonna go back to back. First, we're gonna do the air quality wearable, Don Pedro, and then we're gonna do a speed up, and then we're gonna see you on the other side for INPI.
You can build a compact air quality monitor with an Adafruit Feather in CircuitPython. This is powered by the Adafruit Feather ESP32S2 with a reverse TFT and uses 2 environmental sensors. It's got a PMSA003i sensor for monitoring the particular air quality around you and an SCD41 CO2 for monitoring CO2, temperature, and humidity. Sensor data is displayed on the color TFT so you can easily read sensor values like the particulate matter, CO2 levels, temperature, and humidity. Everything is housed in a compact 3D printed enclosure with swappable faceplate so it can be used as a desktop monitor or a portable wearable. NeoPixel LEDs light up as a visual cue, letting you know the PM 2.5 air quality levels in the area. The built-in ventilation allows for proper airflow so you can get accurate sensor readings. Take this on the go and monitor the environment when exploring your new destination. CircuitPython makes it easy to display sensor data on a TFT screen with ready-to-use drivers and libraries. You can turn this into an internet-connected project with Adafruit I/O and log your sensor data to a custom dashboard. To get CircuitPython on your dev board, head on over to circuitpython.org and search to download the latest firmware. You can get the parts from Adafruit to build this project. Links are in the description. Download and 3D print the parts in your favorite filament to build the snap fit enclosure. Start by mounting the PMSA003i sensor to the 3D printed bracket with machine screws. A short Stemma QT cable connects the feather to the sensor and a JST cable plugs into the NeoPixel stick. Then secure the feather and NeoPixel PCBs to the mounting bracket with screws. A separate bracket secures the SCD41 CO2 sensor to the back of the bracket. The whole assembly can then be installed into the 3D printed case along with your choice of faceplate and back cover. An additional bezel for the TFT display snap fits and keeps the electronics dust-free. This faceplate features slots for strapping on a wristband so you can wear it. We brought this on a trip to Galaxy's Edge and gained lots of insights from the sensor readings. It was really interesting to see the air quality change when moving between locations. We hope this inspires you to use CircuitPython and parts from Adafruit to build your next environmental project.
Alright, and before we go over to INPI, don't forget the code is Adafruit, because we're going to do INPI and then new product. So let's kick it. Alright, INPI every single week. Did you key in for bring you this? This week it is from
XMOS. I don't think we've covered XMOS before, so I'm kind of
No,
excited.
we have not.
I like to always check out some companies that we haven't before. I've seen XMOS stuff for a bit, and they've been very popular on social media. But I've never actually investigated their chips, and so I was like, hey, this is a good excuse. So this week's INPI, it's an eval board, but really it's the X2316 series, which is their latest Core.ai or xCORE.ai model of chips. Comes available in BGA, and also this QFN, which looks like it has some pretty sweet ground and power planes on the bottom. I like that they make chips that are available in QFN for manufacturability. Kind of seems like everything these days is BGA. Okay, so the xCORE is not an ARM Cortex, right? Which is, we covered a couple of what we called like crossover microcontrollers, ultra powerful microcontrollers from NXP, the IMX series a couple weeks ago. These are also what we call crossover, but they're not Cortex series. Instead, it's xCORE. It's their own core chipset, and you see there's basically, it's kind of like two processors, but it's like two multi-core processors. So there's two tiles, what they call, and each tile, maybe you can make this bigger so you can see the text. Yeah,
okay.
possible?
Yeah, I can do that. I just need
Okay.
a second here to scale it up.
Oh, no, just the window bigger.
Oh, you wanted to see that? Oh,
Yeah, yeah.
You didn't want the... You just wanted
The
this.
preview. Yes, thank you. Because
Okay.
I wanted to be able to read all the details. Okay, so in each tile, left and right, they've got the ALU, and they also have their own internal 512 kilobytes of SRAM. And then there's like this communication, the switch, and like packet messaging system in between. And each one has 5 to 8 cores. So you'll see, like, when we go through the list of processors, some are like 2300 MIPS, and some are like 3500 MIPS. That basically depends on how many cores they've got. Each has 500 megahertz clock rate. And then, of course, they've got peripherals. And they also have their own I.O. bank. So you'll see at the top, the I.O. pins are per core. So you can actually have both cores going at the same time doing I.O. control without interfering with each other, which is a common thing when you've got like a microcontroller with dual core. Often the I.O. pins are on a shared bus, and so you can't have both cores messing with the I.O. at the same time. But here, go to town. What you're getting is 10 to 16 cores, all clocked really fast, and this is like a super powerful chip. It reminds it's not at all related to, but it kind of is evocative to me of this like a super ultra powered propeller chip. For folks who remember, that custom chip from Parallax also had 8 cores, special GPIO functions, and was a non-ARM Cortex chip. But gotta give them credit because they wanted to do a chip that was really good at audio processing. It was kind of like the combination of a very powerful microcontroller, multi-core, lots of I/O capabilities, DSP, and now they've added some AI acceleration as well. So basically, it's just really fast, but it's a microcontroller. You have free RTOS running on it, but you're not dealing with Linux, you're not dealing with QNX or whatever. No operating system that takes time to boot. It's instantaneous, which means it's great for appliances, devices, cars, etc. And not only is it really good audio, it's also got pretty good video and camera interface as well. And you can also attach external RAM if you want even more processing capability, like you want more space to move in. Flash isn't built in, you attach flash with like QSPI flash or something similar. But basically very fast. And here's just like another. This one I liked because it showed that the 512 kilobytes of RAM. The MIPI is interesting, 2 lanes, so you can do camera in or display out. Both are supported. Actually, on the dev board, you'll see there's a 15-pin, like Raspberry Pi compatible camera interface. High-speed USB-Phi, so you can do host or peripheral. And then in the middle is that packet switching circuit interface. You can send data back and forth, and you can have external memory as well, LPDDR RAM. And there's ones with tons of pins, so you can connect a fairly big package of memory. Next up, for the processor itself, comes either 60-pin QFN, again, manufacturable. There's also a chunky BGA, but with its 0.8 millimeter pitch, so not too bad to manufacture. They've got an interesting TensorFlow Lite for microcontroller, but they've kind of got like a workflow set up where you can train your TensorFlow models in Lite, the Python API, and then convert it into TensorFlow Micro runtime using their online tools. So, optimized TensorFlow Lite for microcontrollers. Like, you actually do need to have a fairly good processor. I feel like 8 cores running 500 megahertz, you have a chance of it. I'm actually kind of surprised they couldn't run TensorFlow Lite directly, since you can run it on single board computers that are about the same MIPS capability. But instead of most chips where you'd probably have a microcontroller, maybe a separate DSP, or you'd have to really fine tune everything. You just get like very, very high performance. And this is the kind of their money shot graph where they're like, hey, if you had an ARM Cortex M7 running at 600 megahertz, look, we have so many more cores and we're so much more optimized. They don't mention what this mystery ARM Cortex M7 at 600 megahertz is, but I'm betting it's probably the STM32H7 or F7, which is good because a lot of people like to use that chip. That's kind of the highest end microcontroller you can get these days. But they've been hard to get because of the chip shortage. And also, I love competition. I want to have more chips of that power capability available to people. So, we're not just only buying one chip. We have multiple options. So I'm very psyched to see more pressure at the high end of microcontrollers, bringing that price down. And you'll see that the price here is very comparable. Lots of different options for this chip fam. Like I said, different. You can have 2400 or 3200 MIPS. I guess they also have the same logical cores, maybe some are clocked faster. I/O voltage can vary. That's one thing I noticed, 1.8 or 3.3 volts. They all have the same amount of RAM. They have the same number of cores. They have different number of I/O based on whether you have the 60-pin QFN or the 265-pin FPGA. Some do and do not have the external memory and MIPI capability, which makes sense if you're doing graphical display stuff with a nice MIPI display that maybe is 1024 by 720 or something. You'll probably want the external memory to do the frame buffer, and of course DigiKey is a supplier. They also have some very cute dev boards. This is one for the xCORE AI series. Pretty simple, just has the camera connector, which again looks suspiciously like the Raspberry Pi camera. Wi-Fi, native USB, debug USB, and of course audio because they're very specialized audio. You can see on the left, there's the left and the right, there's the GPIO banks. Probably the left-hand side is one core and the right-hand side is the other core. This is the dev board that is actually featured for the XU316 series, and you can tell that it's like, hey, are you designing some sort of like DJ mixer or synthesizer or something? Which this would be a really good job for. Got two MIDI interfaces. I've rarely seen devices that have two MIDI, two RCA, 8 analog outputs, line outputs, through looks like four different on the right, I2S ADC DAC combos. I think it's the TI TVP series. Power supply on the bottom, USB external power, all that good stuff. But one thing I think that they're definitely going after is the family of like synths, DJ equipment, smart speakers. They've already kind of gone after that market a lot. I think also control panels for home devices or for automotive or industrial equipment where you have a noisy background and maybe you want to have speech recognition or you want to do stereo control.
Yeah, what's that right there?
That's clock in. I think that is if you want to, you usually have a crystal for clocking the chip. But I mean, they don't really brag about the low power usage because it's got like 16 cores in it. So, probably you want to mess with your clock frequency to see if you can tweak your power usage, or maybe for precision, you have to have a good steady clock if you want to have your audio coming out at exactly 44.1 kilohertz. So that's a sync signal. You can download the schematics for their Explorer boards, which I found kind of handy because it kind of shows you all the capabilities again, lots of audio functionality, and also how they split up the power supply, which is again has a pretty beefy power supply needed for these chips. Software tools are available. It basically they say use FreeRTOS. Everything is running under FreeRTOS. You do need their compiler because it's not ARM Cortex, so you're not going to use ARM GCC, but they have tool chains available for Windows, Mac, and Linux. And they've got on GitHub a lot of their libraries. This is just a couple of their libraries. They have 76 of them. They have a library for everything that you can do with their chipsets. And I looked at some of the code. All of it looked like it had lots of good example code. One of their things is clearly they're trying to make it very easy for people to transition from using ARM Cortex to using their chips. So they have to go a little bit above and beyond with their SDK offerings. one thing I thought was cool is like, oh,
It's
you know,
USB.
it's USB, and I bet they saw something TUSB, and whenever I see TUSB, I'm like, oh, I bet they use TUSB, and they do. And I would like to point out how cool it is that the TUSB stack is licensed so freely that silicon vendors are now using TUSB, and they're adding support for their chipsets because we do not restrict who gets to use TUSB.
So good, even the biggins use it.
Yes.
Okay.
So very neat. You know, it's a transition because a lot of people using these kind of high-end chipsets, they tend to be using ARM Cortex, but I think the power and functionality, which you're not going to get with ARM, because usually when you see multi-core ARM, it's usually like one big processor and another small processor. Maybe it's a licensing thing, I don't know, but xCORE owns their own IP for the silicon, so they want to toss 16 cores in there, go for it.
Available on DigiKey.
And totally in stock.
Yeah.
And you can see the pricing. It's really quite reasonable. Considering that you get the RAM built in, you don't have to add external RAM. It's almost completely fully built. Like you don't really need a lot of accessories. You need a crystal and maybe some QSPI memory, and you're good to go. Lots of peripherals, lots of functionality. Maybe good for your next audio project. I did notice when I Googled around for this part, a lot of audiophile DACs, like stereo drivers, use the this XMOS series. Yeah.
All right, we're going to play a video, and then we'll see you on the other side for new products.
Voice enriches experience.
Hand right, zoom center screen.
We're being pushed back. Game, find more players.
Here are the other players online.
Alert them that we need some help.
Now we're talking.
Yeah, level smashed.
Game, pause.
New upgrades are available. Do you want to check your options?
Yeah, let's see them.
Emma, here are your options.
Okay.
Dan, here are your options.
No, I'm good.
Buy option 2.
Do you want to use your game credits, Dan?
Yes.
Dan, purchase confirmed. Are there any other options you want to look at? Game t-shirts are on offer today.
No, thank you.
Ready?
Ready.
Game start.
Scan horizon.
Are you turned on by voice?
On NPR.
Yes, over new products. All right, we're gonna hit a revision, and then we got some coming soon. Then we got a bunch of stuff.
A lot going on.
There's a lot of
Okay.
products this week.
Kick it, because last week we skipped. Okay, this week we've got an update to the 2.7 tricolor e-ink display. It looks basically the same as this. It's got that long update to get the red color in, but it's basically a new chipset, the EK79686. The previous one, which was like the IL7368 something, doesn't exist anymore. This is what we got. So this necessitated a little bit of an update to the board anyways, because the flex connector changed the length, and so we had to revise the board, and if we're revising the board, we might as well add an iSpy connector. So now you can connect to this with our iSpy cables, which are 18 pins and kind of like a solderless version of an SPI cable. Good for when you want to wire and mount an e-ink display elsewhere, but you don't want to have a lot of long wires. So still's got the built-in SRAM, so you can use this even with a small RAM microcontroller like an Arduino Uno. Level shifting for 3 or 5 volt microcontroller. Again, iSpy has been added. SD card for storing files that you want to display on your e-ink. We've got 2 upcoming devices from Espressif. This is the ESP32 H2 series. This series of chips, these are developer use only right now. They're still going through certification. These chips are not Wi-Fi. They have Bluetooth and 2.4 gigahertz radio, so 802.15.4, sometimes used for Zigbee or point-to-point or mesh communication. So not Wi-Fi, but probably going to be a lot lower power and really good if you just want to do Bluetooth. So they're kind of trying out new chipset options. This is the raw module, and we've also got the dev board. This chip has native USB, but there's also a UART capable UART add-on for debug, 2 USB-C ports. There's a NeoPixel. There's I think a power measurement jumper. Let's go back over here. I think that's a power measurement jumper, NeoPixel, USB serial converter, reset and boot, and a nice power supply, and all the pins brought out. So I think probably this is designed to target, things that are going to run Matter or Thread or other Zigbee / Bluetooth / 2.4 gigahertz non-Wi-Fi communications for home automation. It'll probably be a good competitor to the ESP32C3, maybe lower power use. And so far, Bluetooth on espressors hasn't been their priorities in Wi-Fi, so it's going to be good to see them, focusing on Bluetooth, maybe getting the low power usage for Bluetooth with better lower numbers. Next up, we've got 2 more UU Gear WidiPi boards. They've been all updated to the WidiPi 4 series. So this one is the L3V7, and the 3V7 isn't version 3V7, it's WidiPi 4. The 3V7 means that thing on the left there is meant for LiPoly batteries. You can plug in any 3.7 volt nominal, 3.7 to 4.2 volt lithium ion or lithium polymer battery. There's a boost converter that'll convert that up to 5 volts, and there's like a memory management system and a real-time clock that you can use to power down and power up the Raspberry Pi. So it's kind of like an uninterruptible power supply, UPS, plus a real-time clock, plus a control. It's kind of like a power management tool for your Raspberry Pi. It comes in the bonnet or fat or micro fat, whatever, mini hat size, but you can use it with any Raspberry Pi that has a 2x20 connector. It comes with a couple accessories. Oh, here's all the GPIO. There's a microcontroller on board, by the way. There's an ATtiny 814, I think, that is used to over I2C to send commands and control it. So if you go, here, I just want to note one thing. This is kind of designed to plug in directly into like your Pi Zero or Pi Zero W. And you see how the socket in the top, the pins of the Raspberry Pi plug through the board and up to it. Now, you could use this with a Pi 4 or any Pi with a 2x20 connector, but you'll want one of the stacking header that extends the pins up, because otherwise it won't be able to. Only the Pi Zero is flat enough for this to sit around the bottom. So you may need to get an extension header, which we stock in the shop and we point out in the description, to lift it up above. Or if you have a Pi Zero and you want to keep it nice and slim, this style is good. There's also the WidiPi 4, which comes with extension header, so you can plug it into your the Raspberry Pi 4, Raspberry Pi 3, A+, B+, whatever. This is a good demo because it shows this doesn't have a battery booster. It has a buck converter, so it's good for if you're running it off of like a AA battery pack or something. It has a real-time clock with a coin cell backup. The coin isn't included because otherwise it's really hard to ship internationally or even to Canada, anywhere. So we do have the coin cell sold separately if you want to add it, but we don't include it in the package for ease of shipping. But again, a power manager with real-time clock and buck converter for any Raspberry Pi on-off switch on the right-hand side. So they do a really good job with the real-time clock and battery management. So we have a couple different options. But again, if you want LiPoly recharging, boosting, use that WidiPi Mini. This one doesn't do LiPoly. It's a buck converter, so it takes, I think, 6 to 12 volts or 6 to 20 volts and converts it down to 5. So it's different uses for different needs. And this one is a normal hat size. That said, it still will plug into a Pi Zero. It'll just stick out kind of overhanging.
What's up?
This is coming out soon, but I want to mention it because the next product is similar, and I knew people were going to ask, when are you going to get the LoRa version? This is a Feather RP2040 with a LoRa 900 megahertz module that you can use to run a LoRaWAN stack, or just LoRa, which is its own protocol. You don't need to run LoRaWAN, which is a type of software stack that runs on LoRa. 900 megahertz means you can tune it down to 868 or up to 915, and then just pick the right antenna, and you're going to still get about 20 dBm output. You have all the feather pins that you expect, 4 analog pins, I think like 20 total GPIO. STEMMA QT on the end there, you can plug in sensors, OLEDs, whatever, NeoPixels, 8 megabytes of flash, that nice RP2040 core, which will work great with MicroPython, CircuitPython, or Arduino, UFL antenna, and the FCC IC certified SX1276 based Semtech LoRa module. So this is coming soon, but I want to mention that we have it because the next product...
So our show besides you, Lady Ada, our community, our customers, our staff, everyone who makes this thing go is...
the Adafruit Feather RP2040 with RFM 69 packet radio. So this is...
Packet fruit.
Not... This is packet fruit. It's not a LoRa radio. It's an RF69. What's the difference? The RF69, which sounds so similar to the RF95, which is the LoRa. This version doesn't do LoRa or LoRaWAN because they don't pay the licensing fee. However, it's great for sending packets of data back and forth between modules. You can get easily 500 feet without much effort, and you can get kilometers with really good antennas and directional gain antennas. But if you wanted to make a simple, low-cost radio node that can go much farther than 2.4 gigahertz, these are great. They use the ISM band in North America. Check your location to make sure that 900 megahertz is your ISM band. We'll have the 433 megahertz version later. It has the RP2040 with 264K of RAM, so wonderful for running CircuitPython. Our Feather M0 RFM69, people were like, this is such a great thing, but you design this before CircuitPython or MicroPython, you run out of memory before you can really do anything, so it only has 32K of RAM. This one has 264K, so you can use interpreted languages like CircuitPython or MicroPython and do your packet radio and have sensors and have data, and you don't run out of memory instantly. Yay! 8 megabytes of flash, you can store data, do data logging, send and receive packets. Couple of antenna options. So if you're cheap and you just want to keep it simple, solder either a spring antenna or just a piece of wire that is a quarter wave or half wave whip for 915 or 868 megahertz. There's online calculators to help you figure out the length of the antenna. Solder it into this little pad called ANT for antenna, and you're ready to go. Like, you're done. It's one solder. Let's say you're like, I don't even want to solder. I want a really good antenna. There is a onboard UFL connector. You can use a low-cost UFL to SMA adapter and then plug in any antenna you wish. That's 868 to 915 megahertz. And boom, you can have a panel mount antenna without any soldering that can go very, very far. You can get a directional antenna, get a Yagi, I don't care, whatever you want to do. And then on the right, you get headers. You can plug it into a breadboard. It works with all of our feather wings. You get I2C, SPI, 4 analog pins, power supply, LiPo battery recharging, regulator, reset and boot buttons, NeoPixel, 8 megabytes of onboard flash. I already mentioned that. And on the very right, there's a STEMMA QT port, so you can plug in all your sensors. You want an OLED. You can actually make fairly complicated sensor nodes with no soldering, which was the goal here, is as much as possible make it so people can get going. But if you want to solder, you can add a lot more power and accessories. So this is our first board of this series where we're trying to kind of replace the Feather M0 and 32.4 line, upgrade them, because those are kind of now 6 to 10 years old. Give them a refresh with the RP2040 chip, which is less expensive than those chips, but much more powerful. So we'll still carry the old ones for compatibility, but I really think, if you're just looking for a new packet radio board, I would push people towards getting the RP2040. It's a nice solid chip, and again, less expensive and more powerful.
That's nice. Okie dokie, don't forget the code is Packet Fruit. You get all that free stuff. We're going to do some top secret while you put up any questions. I have some of them ready to go. We're going to do top secret, and then we're going to answer your questions over on Discord. So here we go. Okay, first up, we're going to play 2 videos. These are top secret things that we're up to. And then, Toddbot doesn't care. Send Todd out a DVI feather wing. It's cool. So he did something neat with it, so we're going to play that. And then, do you want to show anything else, or do you want to do the questions?
Let's do the questions, because
we can do a really big... or we could do a top secret video later and post it.
We'll just post it later, because I want to get to the videos, and then I got it.
Okay, cool.
All right, Leonardo, what is this?
This is me designing the tester for our new RP2040 feathers with radio modules on the end. This is a LoRa 900 megahertz RFM 95. We've also got the version over here where you have an antenna soldered on. The RFM 69, which is a packet radio version. So the tester brains uses the Pico with an SD card, which has the firmware. And then it connects to one of the modules. I usually would use like a breakout, but I only have a feather wing on hand. I got to go to the office and grab one of the modules that matches the right frequency. And then over here is the feather. And so what it does, if you back out a bit, we can see everything. The tester programs the test firmware onto here, which tests all the GPIO and checks the voltages and everything, and then communicates back and forth with this radio to make sure that the radio and the antenna is working. And you can see I've got a little faux antenna, just a basic antenna that connects to the pogo pin here. And then on success, you get OK test.
All right, Lady, what is this?
Well, this is a Circuit Playground Classic, which you might remember is our Atmega 32U4 based Circuit Playground. This was the first version, and we didn't make them for a while because we couldn't get Atmega 32U4s, but hey, chip shortage is over, so let's make some more. We also decided let's redesign this tester board. Originally, this used a Arduino M0 Pro, ancient, which we can't really get anymore. So we're going to update it to our RP2040 Brains board, which does the AVR programming and also can do the USB hosted numeration check. So the board tests itself, and then after it's done, it enumerates, programs the flash, can do the whole thing in about 10-15 seconds, which is great. And then when it's done, you get a nice little rainbow.
Look for the rainbow.
Yeah, so look for the rainbow, and then once these are all tested, we'll get them back in the shop.
And this is a little preview. We sent this out to Toddbot, and Toddbot delivered. This is something
I know he's going to do something cool.
Yeah, so this is
It's a little video synth with using the Arduino Pico DVI library, which is neat because, again, it's always been so hard to do DVI output without using a Raspberry Pi or their single board computer, which, don't get me wrong, they're cool, but it's a lot of heavy lifting to get it going. What I like is how light, it's instant. You turn it on and it's immediately displaying whatever you want over DVI.
Cool.
So looks cool. It's a little chunky, but I kind of like it too. It's got a little bit of that video toaster kind of look.
This will be in our store very soon. Okay, we're going to go right into questions. We have some lined up right away, and then there's some that just came in. Lady Ada, how about you speed round these so we can feed you and convert soup into electronics.
Yeah.
So,
pretty much.
Yeah, first up.
Okay.
Someone has a Matrix portal. It's a great device. What's the best way for them to display their local time?
It's actually really hard to display local time. Local time, you think it's how hard is it? Just look at the clock. But your clock changes twice a year if you have daylight savings time. So what I actually recommend is if you have a Matrix portal, use the Adafruit IO time service, which is free. You do need to have an account, but that's just so we don't get abuse. And forever and ever, you will be able to get your time based on either your IP address or that you tell what time zone you're in. It will always give you the correct time that adjusts for daylight savings and all that good stuff.
Yeah. I think this question was referring to the STEMMA quick and stuff, because we ever thought about working with the company to create standards. Yeah, sort of, kind of. I mean, one of the things that happened in the maker world, Seed had Grove, SparkFun had Quick, and then we had Stemma. We reached out to the different companies. I think this is as good as it's going to get right now as far as compatibility. Like, we decided, let's make sure our thing is the most compatible. But it would be good. Arduino has a totally different thing they're doing. It would be nice for all of us to have a way. I kind of look at groups like the Open Hardware Association. That's where I would hope that would come from, is like, hey, we're noticing here's what everyone's using in the industry. Could we help you come up with a spec, kind of like we did with the Open Hardware Definition? Because, like, for some companies, they'll come up with their own standard, so you're stuck with their thing. We said, well, you can use anything.
I feel like, Quick and Stemma and Pico Dev or whatever have all basically there is a standard now, and it's getting picked up by other companies. I think it's tough because there is no coalition to create standards. And I'll tell you another thing about standards bodies is, like, before you know it, there's like dues and the big companies boss around the little ones, and I think it's right now we have just an open market of ideas. Like we created the Feather standard, and there's a lot of people who make Feather compatibles, and it's cool, whatever. Like, I think that if we'd gotten together and tried to do a committee, it would have taken years to hammer out details. I think, we kind of have a more free-form market right now. But it's working out because everyone's got these open standards and not patented.
I do think that if you make something everyone wants, like TinyUSB, it kind of gets adopted. And
whatever's free is, of course.
And I'm glad it's coming from us because we did a good job and we made a really good open license.
Yeah.
Next up, any updates on the status of Matter? So there's some infighting with some of the different entities in Matter. So we're just kind of watching. We can always spin up a board, but we're kind of figuring out what's going to happen next.
Wait.
Will you still need an airlift to get it on Wi-Fi? Have you tested it with airlifts yet? I think that's for the...
I would actually go with an ESP32 Feather and then add an RFM Featherwing on top, because for Wi-Fi, you're best off having native Wi-Fi. You're going to get the best performance because the packet radio is much slower.
Okay, we're to questions, ideas, a phased array IR transmitter work, IR to CDMA encodings.
There is such a thing as a phased array IR transmitter. That's what Pixmob uses for their light-up bracelets.
Oh, that's cool.
So you can check out what Pixmob does.
Okay. Could one run a private LoRaWAN over a mesh packet radios?
Well, these are not LoRa. These are packet. Like, LoRa is a patented standard that Semtech owns the licensing for. You have to pay more for it, but you can absolutely make any kind of mesh network, address network, point-to-point network with packet radios, no problem.
Okay. For the AdaBox drop, would you be interested in talking about the saga of parsing to redesign parsing? Absolutely.
Yeah.
As we ship AdaBoxes, we're probably going to be filming us shipping them, and we'll probably just do like a deep dive in like what's happened over the last couple of years, because we stopped doing our chip shortage videos because it's changing, but boy, it's been a journey.
Yeah.
Someone designed a cellular IoT RP2040 device with a SIM 808, 3.5 touchscreen TFT breakout, and the HiMax HMO 1B0 color imaging module. Has a right angle SMA antenna on the top, and it's kind of bulky. My question is, what the heck do I call it?
This is like chonk cell.
I
would chonk it.
Ring, chonkaphone.
Chonkaphone. I'd actually ask ChatGPT. It can actually come up with some pretty good products.
I have a chonky phone. What do I call it?
Yeah.
Next up, the RP2040D vibe board. Can you give an idea of how much the process to output the DVI display would take up a CPU of memory? Will there be tons of room to do some big projects?
There's not a lot of room for it. It uses one core. I think it uses either one or both of the PIOs. Maybe it uses one, so there's one PIO available. And then it uses 160K of RAM. So it's a lot. It's beefy, and it's overclocked. So it uses a lot. So you can do some basic projects. I'm not sure that the code will run on like a Pico W. I think it doesn't right now because the other PIO is used for communicating with... the allocation isn't done right for the Wi-Fi. So... It's more of a toy. Think of it as like a DVI toy, not like, oh my god, I really do have like HDMI output for any usage.
You can call that phone Cinder Block. There was that really fat cat that they had to put on like a water treadmill for a while, and they're like, cat's name was Cinder Block. Anyways, them's the questions.
Okay.
So thank you so much, everybody, for hanging out with us this week. We're running a little late, but we're going to get you some food.
I know. I'm so
hungry.
hungry. We'll
see everybody... during the week, we have lots of videos. We're going to post some cool coming soon and prototype stuff since we ran out of time tonight. We'll see everybody next week. Special thanks to Jessie May behind the scenes.
Thanks, Jessie May.
Running some things. And this has been an Adafruit production. This is your moment of Zener.
Bye, everybody.
Bye, everybody.